Okay, so today we are going to finish up section 1 from chapter 1, and the notes are 1-1b, and we're going to be solving linear equations still, but today instead of getting a value for x, we're just going to rearrange our equations for a specific variable. So basically all we're going to do is use inverse operations to isolate the variable. So my first example is the simple interest formula. It's I is equal to PRT, principal times rate times time. So they're asking me, and again, you don't need to memorize any of these formulas or equations. All you need to do is know how to use inverse operations to isolate it. So they're asking me to solve for solve for T, and T is right here. So I'm going to undo or move the P and the R to the other side. Notice that P, R, and T are all being multiplied. So to undo the multiplication, I am going to divide both sides of my equation by the P and the R. That will cause the P and the R to cancel out, leaving me with I divided by PR equals T. So T is equal to I over PR. Just rewrite it with the variable on the left. So all we're doing is moving the letters to the other side away from our indicated variable that we're solving for by using inverse operations. The next one, sort of similar to what we did last week. Now, remember last week you were probably given a problem like x plus 3 equals 4x plus 1. So last week when we did this, we could try to move our x's together and get negative 3x plus 3 equals 1. And then we move everything that's not an x to the other side. And then get negative 3x equals negative 2, divide, and then we actually got a value for x. This time when we isolate x, we're going to have letters in our answer, not just a single number. But our process is still the same. I'm going to try to move all of the letters they're asking me to solve for, and in this problem, it's x. So I'm going to get all of my x's together on the left, and then all of my numbers that don't have an x in them on the right. Now, I still need to distribute, combine my like terms, whatever I can combine. So let's distribute the 3 first. So this would give me 6x minus 15a. I'm going to drop down the plus 4b and then drop down that right side of my equation. The next thing I'm going to do is try to get my variable that I'm asked to solve for together. So I'm going to subtract 4x from both sides. And then I get 2x minus 15a plus 4b equals negative 2. I still need to move all of the terms that don't have an x in it to the other side of the equal sign. So I'm going to move the 15a over. So I'm going to add it to both sides. So now it's gone from the left. Now, notice the 15a and that negative 2 are not like terms. So I'm just going to write them side by side. I can't add those and get a 13a, okay, because the 2 doesn't have the variable a. So then now I'm going to move the 4b over. So I'll subtract the 4b. And again, notice when it gets over there to that right side, there aren't any like terms there. So I'm just going to write it all in one line. Keep them all apart, but I'm moving it to the right side. And now I have one last step. Remember, we wanted to get x all by itself, so I'm going to divide both sides by 2. And now my final answer is x is equal to 15a minus 4b minus 2, all divided by 2. Now, you can leave it like this. However, if that 15a were something that I could have divided by 2, I would divide it. Now, if you want to divide this, you can, But if you think you're going to make a careless mistake dividing, I would leave it like this. Now, it would simplify to 15a divided by 2 is 7.5a. Then I'd have to divide the 4b by 2, and then finally that end. So I wouldn't divide it. I would just leave it like that, because again, 15 divided by 2 doesn't go in evenly. Yes?
Could you do x equals 15a over 2 minus 2b minus 2?
You could leave the 15a over 2. So just be aware that, so you could divide the other two and make those whole numbers or integers, yes. Just be aware that if you are getting something like this on a standardized test, they might leave it like this with the 2 in the denominator. They might divide it. They might do, like Annie said, and leave the 15a over 2 minus 2b minus 1. They could leave it like that. But for my test, you can leave it like what I have in the box. And, don't make it any more difficult and try to divide everything. Common mistakes that people are probably going to make are people are going to try to cross off this 2 at the end. Remember, that denominator needs to divide into all 3 terms, not just the end. So that would be a common mistake that students would make. All right, let's try another one. Here we go again with some principal and some interest and some time. So let's go ahead and solve for r. So my variable r is right here. I'm going to distribute the p first, and then I'll start moving things. So a is equal to p, so p times 1, and then p times RT. Again, remember, we're solving for r, so I need to move everything away from it. So the first thing I'm going to do is subtract this capital P. And then I get a minus p, because they're not like terms, so just write it as a minus p. And then you're left with the PRT. And again, we want to get r all by itself, and it's being multiplied. So to undo that, I'm going to divide both sides by p and t. And then you're left with, these would cancel. And now r equals a minus p over p times t. So just write it there. So again, all we're doing here is rearranging the variables. We do have to distribute, combine whatever like terms we can first, and then from there, isolate the letter that they've indicated. They want me to solve for x. So I have an x right here at the beginning with the 5, and I've got an x over here in the parentheses. So I'm going to distribute. I'm going to distribute this subtraction sign or this negative sign. So I'm going to end up with 5x minus 2a minus c. Then I'm going to distribute the a, ax plus a. Now, I've got an x right here and an x right here. Now, remember when we did this last week, notice we did stuff like this. So let me show you. So again, same thing, 2x minus 4. Say it's a negative 3x plus 5. Again, you're trying to get your x's together. And then you would get 5x. Now, in this particular case, when I go to try to move the x's, they're not like terms. So this one's going to be a little bit different. Once I get my x's on the left and my a's and my c's on the right, then I'm going to have to factor a greatest common factor. So this one's a little different. So let's go ahead and try to get everything away from the x's. So I'm going to add 2a. Gone from the left side, so drop down the 5x minus c, and then the ax, and I can add these and get 3a. Next, I'm going to move the c over. Notice there are no like terms on the right side. So I'm just going to put it all together. So ax plus 3a plus c. Again, remember we're solving for x. So I got an x here and an x here. So now I need to move the ax to the other side. And this is what I was talking about. 5x and ax are not like terms. So I'm going to write them side by side here. I need to get x all by itself. So the way that I'm going to do that is I'm going to factor out a greatest common factor of x. So if I divide both of these by x, I get x is equal to 5 minus a. Now to isolate a, because it's being multiplied by that quantity of 5 minus a, I just have to divide both sides. So I would divide both sides by 5 minus a. This would cancel away from the x, and you're left with x is equal to 3a plus c over 5 minus a. And that would be your simplified answer. So when you have non-like terms of the variable you're solving for, you're going to have to factor out a greatest common factor of that variable you're solving for. All right, again, we're solving for x. So I have an x right here and an x right here. So again, I need to get my x's together and I need to get my non-x terms together. Now, this one you could actually do two different ways depending on which way you moved your variable. So let me go ahead and move my x's to the left. And then I'm going to also show you that we would get a different answer. All the signs are just flipped. So let me move my x's to the left. I'm going to do it two different ways here. And either way is correct. So if I move the bx over here, I get 4a minus ax minus bx equals 3b. Now, honestly, I prefer to keep my variable I'm solving for positive. So I would have actually probably added the ax to the other side. However, this method is still correct. So now let me move the 4a to the other side. And I get negative ax minus bx, and then 3b minus 4a. You could also do it as negative 4a plus 3b. It doesn't matter. Now, notice on that left side, I have my two variable x's here that I need to solve for. So again, I'm going to factor out a greatest common factor of x. I'm not going to pull a negative x out because remember, when you solve for a variable, your variable can never be negative. So I'm actually going to divide both of these just by an x. So I would get x is equal to, or x times negative a minus b. And then drop down this side. Now I have a way that I can isolate x by dividing both sides by negative a minus b. This would cancel, and I'm left with x is equal to 3b minus 4a over negative a minus b. Remember, to cancel things out, it has to look identical. So I can't just cancel out my a's and b's here because the top does not look exactly like the bottom. And that would be my simplified solving for x. Now, let me show you if I would have moved the variables to the right instead, which is also a valid way of solving this. So again, if I take the same question, let me rewrite it. So 4a minus ax equals 3b plus bx. So instead of me moving the bx over, let's say I move the ax over, because I wanted to try to keep my x's positive. I get 4a equals 3b plus ax plus bx. Again, ax and bx are not like terms, so I can't combine them into one. And next I'll move my 3b over. 4a minus 3b equals ax plus bx. Again, we're going to factor out a greatest common factor of x. So then I get x, a plus b. And now to isolate x, we divide by the a plus b. So final answer here is x is equal to 4a minus 3b over a plus b. Now, again, if you move the x's to the left, the answer you got for that one was 3b minus 4a over negative a minus b. If you notice, all of the variables are opposite signs. They're all there, but they have opposite signs. So either method would be acceptable.
So you don't have to vote?
No, just one. So just pick. Either move your variables if you want to stay consistent and always move the variable you're solving for to the left. Know that you can do that. Okay, so either method would be acceptable. You don't need to do both. Let's try another one. Now, this one also I can do two different ways. I could add a 1 underneath the a plus a minus b and treat this as a proportion. Or I can just solve for it. So again, they're asking me to solve for x. So again, let me rewrite it here. If I were to take my equation, I want to get rid of the fraction. So I'm going to multiply both sides by x minus 1. So this would cause this to cancel, and then I would be left with 2a is equal to a minus b times x minus 1. I need to FOIL that right side. So I'm going to get 2a on this side. A times x is ax. A times negative 1 is negative a. Negative b times x is negative bx. And negative b times negative 1 is positive b. Again, remember, we're solving for x. So I've got an x here and an x here. So this tells me I need to move that negative a and that positive b to the other side. So I can add a. So this is, I'm adding a 1a, so this becomes 3a, ax minus bx plus b. Move the b now. So 3a minus b equals ax minus bx. Again, I want to get x by itself. Factor out the GCF. So then you're left with x and then a minus b. And then 3a minus b, just drop this side down. Divide both sides by a minus b. And then x is equal to 3a minus b over a minus b. Now, you cannot cancel that a minus b, okay? Because the top does not look exactly like the bottom. Okay, so that would be your simplified answer. The other way that you could have done this, and you would have gotten the same solving process, is if you have 2a over x minus 1, on this side where you had the a minus b, you could have put a 1 here, and then solve this as a proportion. Multiply this times this, this times this. Once you did that cross products, you would have gotten this same line that I got here. So the process is the same. So if you wanted to solve it as a proportion. again, we're solving for x. So x is here and here. Now, this is the same situation where depending on which way you moved your x's, you could get a different answer. So I'm going to move it to the left first, and then I'll move it to the right and show you that they would be two totally different looking things. The signs are just opposite. So let's say I move the x's to the left. So move the bx over. So ax minus bx plus b squared equals negative a squared. Then if I move the b squared, ax minus bx equals negative a squared minus b squared. Again, factor out a GCF of x, and you're left with a minus b equals negative a squared minus b squared. Divide by a minus b and get x equals negative a squared minus b squared over a minus b. Now, we cannot cancel anything here. If that numerator was just a plain a squared minus b squared, we could factor that, the difference of two squares. However, I can't just take away the squares and leave it because it does not look identical and the top can't be factored. Now, let's say I move the x's to the right instead. So same problem. Ax plus b squared equals bx minus a squared. So instead of me moving the variables over to the left, I'm going to move it to the right. So let's say I move the ax over this way. Then I'm left with b squared, bx minus ax minus a squared. Add the a squared. And then I get a squared plus b squared equals bx minus ax. Again, divide by the GCF of x, and then you're left with x times b minus a squared plus b squared, divide by b minus a, and that's your final answer. So x is equal to a squared plus b squared over b minus a. Again, if we did it the other way, remember our answer was negative a squared minus b squared over a minus b. Notice every single term has opposite signs. Again, you don't need to do both. Pick one way and just stick with it. So either answer here would be acceptable. So you have homework on this. It is page 91, and it's 39 through 57 odd. Tomorrow we will cover complex numbers. Remember when we did the radicals and we broke them down? And I told you that if you had something that looked like, your homework again is page 91. Like this, and I asked you to square root a negative number. I told you that we could not do it. We could not get a real solution here, but starting tomorrow, whenever you see a negative square root, you're going to be able to do it. And we're going to get an imaginary number out of this. It's pretty simple. We're just going to memorize some facts about negative square roots. So this is what we're going to cover tomorrow. We're going to skip over section 1, 2 and go into section 1, 3. So